polyatomic ions are a little bit different than both our covalent and our ionic bonding. So how they're different is if you look right here, you can see that they have a charge. So we're going to count our electrons the same as we have been. That carbon would have 4 electrons here. That oxygen would have 6. But we have a -2 charge. So that tells us that we're adding 2 more separate electrons from what these each have. So we would add up our 4 and our 6 and get 10, and then we would end up with 12 total. Okay. So there's a couple different ways we can look at this. We can look at carbon and oxygen and say, okay, they each want 8, so there's going to be 16 total electrons. This one wants 8. This one wants 8, but there's going to be 3 of these. I'm sorry, I didn't write all 3 of them down. So 8 times 3 then would give us 24. 24 plus 8 would then be 32. And if we go back here, we would have 6 times 3, which would give us 18. And then we would have our 4 here. So that would give us 22 plus another 2, so 24. So the difference here is going to be 8. So we should have 4 different bonds. Okay, so if we look at this, we put our oxygens around our carbon. And if we go ahead and put our bonds in, that would be normally what we would think our bonds would be. Okay, right here. That would give us only 3 bonds. So again, 32 minus 24 gives us 8. 8 divided by 2 tells us we should have 4 different bonds here. So if we go ahead and we draw in our electrons for oxygen, this would give us a full shell here. And if we draw our oxygens in here, that would give us a full shell here. So that gives us 2, 4, 6, 8, 10, 12, 14, 16, 18 electrons. We're supposed to have 24. Carbon needs 2 more here, and oxygen needs 4 more. So if we put a bond here, okay, that would give us our 4 bonds. And then if we put 2 more sets of electrons here, that would give us a full shell for oxygen. So if we go back here, we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We've got our 24 electrons used. We've got our 4 bonds. And if we go back, oxygen has a full shell, oxygen has a full shell, oxygen has a full shell, and carbon has a full shell. Now what's a little bit different here is we have to show that this is an ion. So we need to put brackets around it and show that this has a -2 charge, or when we go and add up, if we're just looking at this, we wouldn't know that we needed those 2 extra electrons, and it wouldn't seem right. So always put your brackets around your polyatomic ions. Now what happens is we have this covalent bond with a charge. So now that we have something with a charge, it can then combine with something else that has a charge. So if we look at the atom we have here, this we said has a -2 charge. This is positive when it loses its electron, and this is positive. So if these were the donors of the electrons that this one gained, we now can have a compound written with all of these together, because +1 + 1 - 2 gives us 0. So we could have 2 NAs and a CO3 all put together to make a new compound, sodium carbonate. Okay, so that's our sodium carbonate. And it's, again, because of these charges, we have a covalently bonded atom with a charge, so the charges then can join together to help us make that new compound. Okay, and this basically shows the same exact thing that I just did. So that's how polyatomic ions work. Basically the same thing, but you're just going to add in an electron. If we would have something that would be positive, like this polyatomic ion, okay, nitrogen has 5, each hydrogen has 1. So that tells us we would have 9 electrons here. That should tell you something's wrong if we get an odd number. But this +1 here tells us that we had to lose an electron, so that this structure would have 8 altogether. So if we put our 4 hydrogens around our nitrogen here, that gives us our 8 electrons. We're full here, we're full here, we're full here, we're full here, and nitrogen is full. So again, we have to show that this is an ion, and this would be a positive one. So basically the same thing as the negatives.